Hello, welcome back to Matrix and Determinants, specifically the applications. So we want to continue the solution of simultaneous equations by matrices. Last video we checked the procedure for solving linear simultaneous equation with two unknowns, but today we'll be checking the procedure for three unknowns. Okay, so the first step is to write the equations in the form of a1x plus b1y plus c1z and equates to the the constant rather, a2x, b2y and c2z to the constant 2, a3x, b3y, b3y and c3z to d3, the Roman figure 2. So the next is to write the matrix equation. Write the matrix equation corresponding to these equations. Okay, that is coefficient of x a1, a2, a3, coefficient of y b1, b2, b3, and coefficient of z c1, c2, c2. Then multiply with the unknown variables x, y, and z. Then equate it to the constant d1, d2, and then d3. So the next step is to determine the inverse. Determine the inverse matrix of a1, a1, a2, a3, b1, b2, b3, c1, c2, c3. So please kindly check our previous video on how to find the inverse of a 3x3 matrix. Okay, the fourth procedure is to multiply each side of 2, each side of figure 2 by the inverse matrix. Then the last, just to solve for x, y, and z by equating the corresponding elements. Okay, so let's check an example. Okay, let's do this better. Example 1. We have used matrices to solve the following. Simultaneous equation. Equations. We have x plus y plus z equals minus 4 equals to 0. Equation 1. 2x minus 3y plus 4z minus 33 equals to z equals to 0. Question 2, 3x minus 2y minus 2z minus 2 equals to 0. Equation 3. Alright, so the solution now. For our solution, the first thing is to rewrite our given simultaneous equations in the form of this h, y plus z by taking all the constant to the other side. Three 3y minus 2y minus 2z equals to 2. So the next thing is to write the matrix equation. So writing the matrix equation, we are going to have the coefficient of x, we have 1, 2, 3. Coefficient of y, 1 minus 3 minus 2. Coefficient of z, 1, 4 minus 2. Then times the unknown variables, that is x, y, and z. Then equate it to the constant 4, 33, and then 2. So the next step is to find the inverse of 1, 2, 3, 1 minus 3 minus 2, 1, 4 minus 2. So you can check our previous video together, and don't forget your inverse is given as A inverse A equals to 1 over determinant of A adjunct A. So we can check our previous video and also find that. So the inverse of A is given as 14, 16, 5, 0 minus 5, 5, 7 minus 2 minus 5. Check our previous video and you'll be able to get this. Then the next step is to multiply. So that is the, sorry, this our, let me add the determinant here. Let me put determinant here. One over 35. So this is the determinant, this is the adjunct. This is the adjunct, that is the transpose of the cofactors. If you check our previous video, we have better understanding on that. So multiplying this with this, let me name this equation star. So multiplying that with that, you are going to have, don't forget, if you multiply the inverse A with inverse A, you are going to have a unit matrix. Then the unknown variable, also multiply it with the constant 14, 16, 5, 0 minus 5, 5, 7 minus 2 minus 5. Then our constant 43 and 2. So what we just did is we multiply each side of this with the adjoint. We multiply this with the inverse, we are going to have unit matrix. Then we also multiply it with this. So let's see what you are going to have. 1 times d, this is just 1 times this, you are going to have x, y, z. X, y, z. And over 35. So don't forget your rule, that's minus row times column. So we have 14 times 4 plus 0 times 33 plus 7 times 2. Then we have 16 times 4 plus minus 5 times 33 plus minus 2 minus 2 times 2. Then we have 5 times 4. We have 5 times 33. And then we have minus 5 times 2. So solving this, we have 1 over 35. We have 14 times 4 is 0, 7 times 2, 14. That's 64 plus 4, we have 70. So we have 64, we have this and this, we sum it together, we have minus 105. This 20, this 15, this minus 10. So if sum it together, so we have 175. X, Y, Z. So if we use that 35 to open the bracket, 70 minus 35, we have 2. Minus 105 divided by 35, we have minus 3. And 175 divided by 35, we have 5. So we can now compare the corresponding value in order to get our non-variable. So our x equals to 2, y equals to minus 3, and z equals to 5. And that gives us our result. So you can try this. Use matrices to solve the simultaneous equation given. We have 3x. Okay, let me give you this. We have 3a plus 4b minus 3c equals to 2 minus 2a plus 2b plus 2c equals to 15. We have minus 7a minus 5b plus 4c equals to 26. Okay, so you can try this on your own, and then I believe you're able to get that. So thank you so much.